Hi folks, today we are going to return to the example that we did in class, our little bank simulation. So just to remind you, very simple process. People come in the door every 2 minutes following an exponential distribution. They get into the wait line. The wait line has a capacity of 8 people. They go straight to the teller. There's only one teller there right now. It takes 2.4 minutes to process a customer, and the standard dev is 0.5 minutes following a normal distribution. And when people are done in the system, they leave. So we send them to that virtual, remember it's that virtual wait line. So basically it's that buffer that we set up at the end of the process, simply just to get SimQuick to capture the number of people that have basically made it through to the end of the process. So we don't put a limit on the capacity, we allow it to count as many people as naturally make it through the process. So we set the capacity to unlimited. The time period that we were modelling was 9 till 11 a.m. and because the bank opens at 11, there are no customers in line at 9 a.m. So the initial number of customers in line is 0. So just in terms of good process flow map practice, what you're seeing on the screen right now would constitute good practice. Each activity is listed going left to right. Each buffer or wait line has a capacity attached to it. The door always has the arrival rate listed, and then each workstation will list the number of employees and the processing time per customer. Okay, so when we ran the model the last time, here's the results that we got. So looking down through, we have our entrance of the door. Now remember our little descriptor sheet that we looked at in class. So what you see on this descriptor sheet that's in your PowerPoint slides is literally, as the name suggests, a description of what happens or the data that's recorded for each part of the process. So for example, we'll only ever have one entrance. So what's recorded for the entrance is the number of people entering the process, the number of people unable to enter. And remember, if the wait lines are backed up like they are in a natural system, if there's nowhere for people to stand and nowhere for people to wait, they go away and they leave the process. So if when you're simulating a process, the lines get full, it will do what happens in reality and it'll send the people away, and that's the number of customers unable to enter the process. The service level is the percentage of customers that are actually served. So when we look at our results sheet then, what do we say about the process? We say that 53.4 people approximately were able to get into the process. 7 people, because the process got backed up and the lines were full, were not able to enter, giving us a service level of 88%. So that 88% is simply going to be the 53.4 divided by the total number who arrived, which is 53.4 plus our 7. And that gives us our approximate 88%. So that's what's happening with our entrance. Okay, with regards to our workstation, so for every individual employee that we have in the process, the information you're going to get about that employee is exactly the same. What we are interested in is 4 metrics, these 4 here. So let's start down here. Fraction of time working is simply the utilization rate, so it's a percentage. So if I'm working 100% of the time, that will show up as 100. The amount of time I'm blocked, or percentage of time that I'm blocked, is the last entry that you find out about your workstation. And then to find out, don't forget we've got 2 types of idle time. We have got a blocking delay and a lack of work delay. So the simulation automatically reports the blocking delay. So if you know your blocking delay and you know your utilization, well, the difference between 100% and those 2 things is your lack of work delay, and you'll see that when we run through putting the results together. So essentially utilization, blocking and lack of work should add to 100%. Work cycle started is the number of customers that is processed by that individual employee, so how many customers they get through in the time period. And then mean cycle time, int buff stands for internal buffer. So mean cycle time is the average amount of extra time people spend at that teller if the next part in the process is backed up. So there is a correlation between this extra time for the customer here and the percentage of time that the teller or the employee is blocked. So if you've got blocking for the employee, which means they cannot move to their next customer because the process is backed up, that typically means that the impact on the customer is they end up being stuck at that station or that activity for a little while longer until the system clears up and is not backed up anymore. So for every employee, there are the 4 things that I expect you to be able to report. For every line or every wait line, I expect you to be able to report 2 things. The average number of customers in line, so that's your mean inventory. Remember, inventory in these systems for us is customers. So the mean number of customers that are in line at any point in time throughout the simulation. And then mean cycle time is the average amount of time that the customer spends in line. So that is the setup for every line that you have in the system. Now don't forget, because we're not using that exit function on the control panel on SimQuick, because we don't have customers leaving according to a specified schedule, what we do is we set up that served customers buffer or waiting area, and what the purpose of that is to give us a final count or a throughput rate for the amount of customers getting through the system. So for served customers, you're only going to look at final inventory and pick that off as your throughput rate for the system. Okay, so there's our results, and that's how you interpret them. For no matter what simulations we run, you pick the same statistics off about the entrants, the same 4 about the employees, the same 2 about every line, and the same 1 about your throughput rate or served customers at the end of the process. Okay, so what we did the last day in class, having reviewed how to interpret the results, we took a little look at our results and we said, well, the first thing that we've got to do before we can trust the output of the simulation is validate it to ensure that what the simulation is reporting is what actually happens in reality. So to validate, we go through a 3-step process. We validate arrivals, so the amount of people that are coming into the process, do they equal what we expect to see in theory? So if we look at arrivals up here, well, according to our process flow map, we expect people to come in every 2 minutes following an exponential distribution. So if they're coming in an average of every 2 minutes throughout a 2-hour time period, well, that's 120 minutes divided by 2 will give us approximately 60 people arriving in within that 2-hour time period. If I look at my SimQuick results, I have a total arrivals of 60.4. Where did I get that from? 60.4 is 53.4 who was able to get in, and the other 7 who arrived who are not able to get in. So in total, that is 60.4 arriving in. So as you can see, they're approximately equal to each other. So we say, okay, simulation is modelling arrivals as we would expect. Then you check to see if the simulation is modelling kind of the middle part of the process as you would expect it to. So you look at utilisation for each employee. Now here we only have 1 employee. So the first thing you do is you say, okay, how many customers would they process if they were working flat out at 100%? What's the basic amount of people that they would process? And in this case, it's 50. So that's 120 minutes divided by 2.4. So if you've got 120 minutes available, divided by 2.4 minutes per customer, I can get through 50 customers in that time period. Now, if I look again at my results and I look at my fraction of time working, that's 95%. So theoretically, if I'm working at 95% utilization, well, that's going to be 50 customers multiplied by 95%. So 50 multiplied by 95% is 47.5. And if I look at SimQuick and I look at my work cycle started, so how many customers I got through, it's 47.95. So these are approximately equal. In theory, I should get through 47.5. The simulation is getting through 47.97. So we say it modelled it okay. And then the last part of the system that we check is the end of the process. Are the amount of customers getting through the process or the throughput rate equal to what we expected? So our expected throughput rate In this instance, we only have one employee, so the throughput rate for the system is equal to the throughput rate for that employee. So the throughput rate for that employee is theoretically at the 95% utilisation that it's at, is 47.5. And then if we look at the throughput rate for our served customers, you'll see that the final inventory is 47. 47 approximately equal to 47.5, so we're okay. So let's go next to recording our results. We know that the simulation or the process is working the way we want it to. We can trust the results and we can move on. So we shall do that in the next portion of this exercise.